This tutorial mainly I just want to talk about this. Okay, injectivity, surjectivity, and bijectivity, which is the first page. I mean, in the second page. This page, propositions, are they important? Yes, but we don't have time to do all of them because I want to keep you here for like 3 hours, and I know you cannot digest all of that. So please just click this link to watch it. Yeah. So in this video, I will go over everything and I'll talk about this example as well. So this part, basically, if you know the definition and you know this example very well, you're pretty much all good. There's not much anything else left. If you understand all 4 of those, you understand those, you're pretty much good. I know the definition, of course. The definition is not typed here, but it's on Discord, and I took a screenshot, so know that as well. But back to this injectivity, surjectivity, and bijectivity. This part is extremely important because the next part, which is cardinality, which requires you to go like construct a bijective function yourself. So if you don't know what's bijectivity, you will be in trouble. This part is a huge part for your final exam as well. So you want to make sure you understand that pretty well because it's going to be on this quiz, next quiz, and final exam. And it's going to be a big part of your final exam. So make sure you understand it. And now let's actually talk about it. First of all, injectivity, the definition. You can see that there are 2 definitions here. The first one says, if for every xy in A is a domain, x1 does not equal to x2. Okay, so which means that if I draw a graph, let's say I draw a function here, just some random functions. Okay, so this is f of x, for example, and you pick 2 x and they don't equal to each other. So for example, I pick this one. Okay, and maybe I can pick this one. So let's say this is my x1 and this is my x2. So they're saying, well, f of x1 does not equal to f of x2, they don't equal, implies that f of x1, so this is f of x1, and this is f of x2, implies that they also don't equal, then it's an injective function. So in this case, for the x1 and x2 I picked, it seems like, oh, they don't equal. But we need for every. Okay, the key word is for every x1, x2, they don't equal to each other. So no matter what I pick, so for example, I can change this x2 to a different x2, and you will see that, well, they're gonna equal. So for example, let me change it to here. Let's let this be my x2. And you'll see that, well, in this case, my x1 equals to f of x2. So you can see that 2 inputs map to the same output, which means that it's not injective. Okay, so not injective means 2 input map to the same output. Injective is the opposite of that, which means as long as your input are different, your output should be different as well. So the first definition, I can rewrite it as different input give different output. Okay, so you cannot have 2 x map to the same y, basically. Okay, so that's why we call it 1-to-1. It means that 1 input map to 1 output. You cannot have 2 inputs map to the same output. That's going to be 2-to-1. Does this make sense? So far, it's being recorded. Horizontal line test. Yes, I'll get there. I'll get there. But right now, the first definition is what it's saying. So when you do proof, this is what you need to prove. You need to prove that for every x1, x2 does not, in A, if they are not equal, then f of x1 is not equals to f of x2, which one of you mentioned horizontal line test. So yeah, horizontal line test is to check if a graph is injective or not. So let me write it here. Checks injectivity. Okay. However, most of the time you will not be given a graph, which means you cannot really use this. So in this course, for 102, you pretty much never use horizontal line test because will never give you a graph. And because, well, graph is not a proof, so you cannot just randomly draw a graph and apply a horizontal line test and tell us it's not injective. So this is good for you to check, but it's not a proof. Okay? This, you cannot use it as a proof. So let me write it down, because if I don't write it down, people will use it as a proof. So good to check, but it's not a proof. So you can use this to justify your calculus course, but not in 102. In 102, what do? You use a definition. So this is the first definition you can use, which is different input will give you different outputs. Okay. The second definition you can use is the contrapositive of it, which states that for every x1, x2 in A, if the output is the same, then the input should be the same as well. So this is a contrapositive of the original one, which states that same output implies same input. Okay. So if you pick, this is like harder to explain because they assumed you have the same input, so you should not get different output. I mean, if you have the same output, you should not get this different input. This one, the number 2, is the one we use the most. So this is our most commonly used definition. Okay, mostly commonly used definition, which means most of the injectivity questions you use this definition, so you should know it by heart, okay? So in practice, what you do is you suppose this and you show this. So let me write it down as well, because people, if I don't write it down, people don't know this is your assumption, and this is what you need to prove. That's injectivity. Does this make sense to people? Injectivity? Are you guys good? Yeah? So, let me ask you a question, okay? I don't even know where to write it. Let's write it here. So, let me ask you a question to test your understanding. So, question. Sorry. Let's say, I have a function that's mapping from integer plus integer to what? To integer. Okay. And I'm not gonna define a property because I cannot think of a function at the moment. Let's just say f a b equals to y. Okay. Where y can be anything. Now, okay. Now my question is, if we try to prove it's injective, actually I feel like I should give you a real function, but whatever. Let's just call it y. Sorry, because I need to come up with a function that's actually injective, and at the moment it's kind of hard. So let's say, to prove it's injective, what exactly do I need to do? What do I do? Anyone? What do I do? No, that's not the definition. Also, no. Okay, guys, read the definition again. First of all, your A here is a Cartesian product. So what are the elements in this Cartesian product look like? It's not just X or Y anymore. That is correct. That is correct. Okay, nice. Okay, this is important. Okay, because every time we have Cartesian product, people freak out. So I have to make sure you understand this. To prove it, you need to suppose. Actually, I should write a property. You should let's say let A1, A2, actually A1, B1, A2, B2 be elements in the domain, which is Z cross Z. Okay? And then suppose F A1, B1 equals to F A2, B2. And then prove what? Prove A1, B1 equals to A2, B2. Okay, this is what you need to prove. Although what you guys said are correct, we need A1 equals to A2, B1 equals to B2, but eventually your conclusion should be this. And to get this conclusion, you need the two equations you guys mentioned. Does this make sense? Is this clear? So you guys see, This is basically your x1. This is your x2. So keep in mind, your domain doesn't have to be one set. It can be a Cartesian product, which you need to understand what are the elements inside look like. Okay, this clear? Got it? Everyone's clear about this? Okay, now let me ask you another question. How do I prove it's not injective? It's not injective. Now what do I need to do if I want to show it's not injective? Counterexample. That's correct, but I'm looking for exactly what do I need to show. So I need to find what, and what. And what? Yes, we do need to use counterexample, but what exactly do I need to show? Okay, A1, B1 equals to A2, B2, and two inputs go to one output. Okay, idea is correct. Okay, but I'm going to write it more specifically in case people don't know what to do. So what you need to do is you need to find A1, B1, A2, B2 in this Cartesian product, and you need them to satisfy A1, B1 does not equal to A2, B2. But their output is the same. Okay, so this is what you need. You need different input, but same output. Does this make sense? So everything I wrote down, you need to actually show them. Okay, so your solution, you should have all of those, except you change those to actual numbers, maybe. Okay, you need to actually show they are not equal or equal. Does this make sense? That's correct. Okay, so this should make sense to you. Okay, now I have another question. So if we look at this part, okay, now let me give you a specific example. So for example, I have 1, 1, and I have 1, 2. Can they work as my counterexample? Can I say they don't equal to each other? Or do I have to make sure A1 does not equal to A2, B1 does not equal to B2? What do you guys think? Do they equal to each other? Yes, that's correct. Okay, they don't equal to each other. Okay, so you don't have to make sure both coordinates don't equal to each other. As long as one of them is different, then the whole coordinate is not the same. So if you think of it as a coordinate system, you will know that they are not the same dots, right? This is 1, 1. And 1, 2, 1, 2 is here. So you see that they are not the same dots. So you can do that. Okay, so move on. This is injectivity, and I wrote down what you need to prove. For single variable, should be simple for you because we'll do right here. Okay, that's why I'm using Cartesian products because it's not really listed here. Because some of you might be confused. Now let's move on to surjectivity. Surjectivity is basically you need to show that for every y in the codomain, there is at least one x in the domain such that f of x equals to y. Do you guys think this is familiar? Isn't this familiar? Remember the three things we mentioned before? Find your x, find the x. 2, show it's in the domain. Show x is in the domain. And 3, check f of x equals to y. What is this? We've mentioned this many times. What is this? Image proof, exactly. Okay, this is the second direction of the image proof. It's exactly the same thing. Okay, you have three things to do. 1, find your x. 2, show x is in the domain. 3, check f of x equals to y. Does this make sense? So there is not much to talk about. Okay? Except sometimes it can get complicated when you have Cartesian products. And so far you've never been tested on Cartesian products. So I don't know if you guys are familiar with it. Are you guys okay with Cartesian product kind of image proof? Yeah, you're good. Okay, cool. We'll see if you guys are good when we do examples. 4 is f is bijective if it's both injective and surjective, which means if you want to prove it's bijective, you have to prove it's both injective and surjective. So 2 things you need to prove. One thing that I want to mention because people always do this is about inverse. So let me write it here. Inverse of a function. Can someone tell me how do we know if a function has an inverse? Anyone know? Yes. Arson, yes, it's always the second direction of the image proof. For surjectivity, the image proof, do we have to plug in X? You should. The thing is, the proofs in lecture or tutorial, they are usually not a full proof. It's just like in tutorial, you already have to write a full proof either, because we just don't have enough time. But when you do your homework and when you do your quiz, you should write it a full proof. It's bijective, that's correct. A function has inverse if and only if it's bijective, not just injective. Now, why you guys nerd in calculus said it's 1-to-1, that's correct, but in calculus, they assume all functions are surjective. So they don't define a codomain for you. Your codomain is just your image. That's why they don't have the surjectivity part. But the real thing is actually a function only has inverse if it's bijective. So that being said, you cannot try to find the inverse directly without saying it's bijective already. So that being said, this is why when we do rough work to find the x here, I always tell you, do not include your rough work in your solution. Why? Because when you do the rough work, you are pretty much assume the function is bijective already, which is what you need to prove. Okay? So we cannot make that assumption. That's why putting the rough work in your solution is wrong. You should never put it in your solution. Does that make sense? Because we don't know if it's bijective yet. So you cannot really find the inverse. We don't even know if it exists. Cool. Let me write it here. Only exists if the function is bijective. Okay, now I'm gonna do examples. There are 4 questions that I want to go over. But before that, let me just tell you the classic questions in this course. Where do I write it? It's right here. What do you guys think are the classic questions in this course? What kind of function do they test you on? What do you think? Anyone want to take a guess? Cartesian product, that's correct. Yes. 1 is Cartesian product. Anything else? Absolute value, that's correct. That's another good one. 2, absolute value. Anything else? Piecewise, that's correct. Okay, you're getting there. Anything else? Trig? No, we will barely test you on trig. Rationals? Oh, barely. Rationals are more common in image question, like a one variable image question. 4, I'm gonna say the combination of the above. So we can put all of them together. So I can have Cartesian product with absolute value there. I can have Cartesian product and piecewise function. I can have all 3 together. Because absolute value is basically a piecewise function. Those are the classic questions that you 100% sure should be very familiar and comfortable with them. Right now, I'm just gonna stop here and we'll just do some examples. Actually, I want to make it smaller. So where do you find those questions? I think I mentioned them many times, right? So where do you find those questions? Here, this channel has a lot. I mean, not a lot, has some. This channel has a lot. I mean, actually not a lot either. So this channel has some. So you see those image questions. Let's turn them into those few. There's a few. Yeah, just turn them into bijective functions. And this video has a lot. This video has a lot, which you can practice on as well. So yeah, there are lots of practice you can do. But right now, I want to do those 4 because those 4 and combinations of them basically cover everything you might be able to see. So let's give them a try. The first one is a Cartesian product mapping to one single thing. So what do you guys think? Do you think it's injective? Injective? Do you think no two different output, no two different input cannot be the same output. What do you think? Injective or no? Is it injective? You don't think so? You think so? Anyone else? Not if A and B are the same. Not injective. That's correct. Okay, I see some counterexamples. It's not injective. There are many counterexamples. You can pick, as Anushan said, you can pick 2, 3, 4, 5, right? Then you all map 2 minus 1. So just think the difference of two numbers can be 1, and you can have many natural numbers that their difference is 1, right? And you can have infinitely many natural numbers that their difference is 0. You can have infinitely different natural numbers that their difference is 2, 3, 4, 5, and so on. So this part should be simple for you, I hope. What about surjectivity? What do you think? Do you think it's surjective or not? Yeah, it's surjective. Why? How do I, let's say, given y be in natural, what do I use as my A and B? Anyone? B can B be 0 though? Keep thinking, you're getting there, Okay, B, I would not use X for any Y, because output we will use Y. Okay, what about, how do you know if B is a natural number? Because, for example, my Y, let's let it be 3, right? Let's let Y be 3. Then minus 3 plus 1 is -2, which is not a natural number. Set B as 1, okay? What about A? A is A plus 1, B is 1. Okay, Y plus 1. Okay, again, what if my Y is -3? Then A is not. Do you guys see it? Still no. You're getting there, but no. Anyone else wanna give it a try? Do you guys see the problem here? I hope you can see the problem we have here. The problem is I need to make sure they are both natural, but if my Y is a negative number, that might not work, right? So what's a better way to deal with it? What do you think? You do by cases. That's correct, okay? Does this make sense? You see that once you give it a try a few times, you'll see that the problem is when Y is a negative number, I cannot make sure my A, B are naturals anymore. So it's better to do cases when it's positive and when it's negative. I pick different A, B so that I can guarantee that they are natural numbers. Does that make sense, everyone? Yeah. So the positive or non-negative cases, we're done with it. So I'm going to write down the proof, and you can, when I write it down, you can keep thinking what happens if Y is negative. Okay, so you can keep thinking, but I want to write the proof down. So let's write it down here. For A, it's not injective. And the reason is that, where is it? Okay, so consider, let's say 1, 1, 2, 2. They are both in natural Cartesian product natural, and they don't equal to each other. However, f of 1, 1 equals to 1 minus 1, which equals to 0. And maybe I'll make it the next line. And f of 2, 2 equals to 2 minus 2, which also equals to 0. So this equals to f1, 1. So clearly it's not injective. And now we discover that it is surjective. And we discover that we need to do cases. We highlight this. Not injective, it's surjective. But we need to do cases, so let y be integer and discuss cases. The first case is if my y is greater than or equal to 0, right? Then some of you already picked the right one. Consider, we can fix b to be 1, so consider y plus 1, 1 in natural Cartesian product natural, and f y plus 1, y plus 1, 1 equals to y plus 1 minus 1, which equals to y. So the first case is done. Now you should think about, well, if my y is less than 0, then what do I do? Okay, so again, any suggestions? So someone suggested 1 minus y. Okay, it's correct, but can someone tell me how did you come up with it? Because this part might be hard for people. Anyone wanna tell us how did you come up with the solution? Yes, basically that. Okay, so a lot of time when we have Cartesian product, we might want to set one of them, fix one of them, and try to find the other one. So in this case, in the first case, we fix B, we fix this, right? So if you basically want this, we use a different color. So we want f of 1b equals to y, right? And 1b is 1 minus b, and we want this to equal to y, which means b equals to 1 minus y. Okay, so fixing one of the variable is a very nice thing to do. Just like in the image question, that's what we did as well. If you watched any of the video, you'll see that I always do this. Okay, I always fix one of them and try to find the other one. And the problem here is we're left with one problem. This one clearly is a natural number, but why is this one a natural number? Anyone? Why is this a natural number? You need to tell us why, right? Since y is negative and should have a negative y is positive. Okay, nice. So you're getting there. Okay, so let's we need to write it down. So let's write it down. If y is less than 0, oops, my bad. Negative y will be greater than 0. And negative y plus 1 will be greater than 1. Okay, so now consider 1 minus y. This should be in natural cross natural. Right, and we can check f of 1 minus y equals to 1 minus 1 minus y, which equals to 1 minus 1 plus y. So that's y. Okay, so in both cases, we've shown that there exists at least one x or one element in the domain such that f of this element equals to 1. Because we've done this, that means the function is surjective. So we can make the conclusion. We can say hence f is surjective because it satisfies the definition. Does this make sense? Yep. Okay. You're all good. We don't have to say y is an element. What do you mean? Y is not an element of that. Y itself is not an element of natural cos natural. Y is an element of integer, okay? Oh, okay. No. F of natural is not an element of natural cos natural. So y is coming from the codomain, which is this. This is where y is coming from, and this is where your AB is coming from. And once you put all of those in, it will give you a integer instead of natural. Okay. Any other question before we move on to part B? Let me add a page here. You're all good? Okay. Let's do B. Okay. Let's put it here. Okay. This is B. First, let's decide if it's injective or surjective. What do you guys think? Is it injective? Is it though? G of 1 is using this piece. That's negative 1. Okay, and G of negative 1 is 1. So your counterexample does not work. So far, I haven't seen a single correct answer, so you should keep trying. Okay, you know what? Let me draw a graph for you. Okay? Because this is mapping from R to R. If the domain is the real numbers, you can basically draw the graph to determine, right? You can basically draw the graph to determine if it's injective or surjective. So let me draw the graph for you. Oops. Okay, so let's see. If it's less than 0, it equals to x squared. So this is what it looks like. And there's a hole here. The hole is not very clear, so okay. And if it's greater than or equal to 0, equals to negative of x cubed. So x cubed on this side looks like this, right? Negative of that means that you do symmetric of that, or something like this. Okay? And at 0 equals to 0, so I'm gonna remove this hole. This is what it looks like. So with this graph, what do you guys think? It's injective. Yes, it's injective and it's surjective. Okay, does this make sense? So that's a hint, not hint. That's a trick for you if you're. Let me write it down, because if I don't write it down, people will not remember what I said. If our domain is the set of real numbers, we can try to draw the graph. Draw the graph to determine if it's injective. To determine injectivity and surjectivity. Surjectivity. But one thing I want to emphasize that graph is not a proof. It's not a proof. So it should only help you, but it's not how you're gonna justify your answer. Okay? Yeah, so it's like help you in your rough work, but it should not be part of your proof. I mean, you can draw it, but that's not gonna be the proof. Okay? So now, this is what I really want to do, because piecewise function showing injective and surjective is really hard for people. And the key here is you need to discuss cases. Okay? For both injective and surjective. The key here is you need to discuss cases. So key here is you need to discuss cases. So how do you discuss cases? You split it into two parts. If you have two pieces, you have 2K. You split it into those. If you have 3 pieces, you split into 3 pieces. Okay? But here, basically, you need to talk about if your input, so let's say A and B, right? You need to talk about if you're, let's say, both negative, both positive, one negative, one positive, and so on. So you should have 3 cases or 4 cases in this case. Okay. So let's prove it. Right here, G is injective. Y. So let's discuss cases. Let A, B be elements from the set of real numbers. And I'm gonna discuss a few cases. As I said, they can both be positive. Suppose A, B are both positive. And G of A equals to G of B. Then, because they are both positive, they are both using this piece. Right? So then we have negative A3. Negative A to the power of 3 equals to negative B to the power of 3. And this implies that A cubed equals to B cubed, which implies that A equals to B. Okay? So the first case is done. Second case, they might both be negative. And G of A equals to G of B. Then they are both using the first piece. So I have A squared equals to B squared. And you can take square root, which will give you absolute value of A equals to absolute value of B. And because they are both negative, since A, B are both negative, we can have, you can just say you can have A equals to B, or you can do a little bit more. You can say negative A equals to negative B, which implies A equals to B. Okay? So far, so good for the first 2 cases. Can we ignore? No, you cannot ignore. Divide where words. Oh, you don't need to describe what you did. So when you say divide both sides by -1, that's describing what you did. You don't need to describe that. You need to explain. So for example, the explanation I did here is right here. Right? I got absolute value. The reason I can take it off like this is because they're both negative. So this equals to this equals to this, so they equal to each other. So you don't need to tell us what you did. You need to, explain why you can do that. And the explanation here is right. No, Shreya, not equal does not mean it's not injective. It's just like you pick two not equal. Line above here. Yeah, you multiply by -1, there is no explanation needed because it's inequality. If it's inequality, you need to explain. Like inequality, because you multiply by a negative number, you flip sign, right? So that part, because you flip the sign, you need to explain why you flip the sign, which is because you multiply by a negative number. But because we have equality here, nothing is changing, so you don't need to explain when there is no change, right? Okay. Now let's do the other two cases, and you'll see why you have to do them. Suppose one is positive and the other one is negative. So let's say suppose A is greater than or equal to 0, B is less than 0. Okay, so here, they don't equal to each other, that's correct. Okay? But you cannot say that we're done because, well, they don't equal to each other. It doesn't mean they equal to each other. What if they don't equal to each other? Then it doesn't satisfy what we want to prove, because you want to show that if they equal to each other, then they equal to each other, right? So if they don't equal, maybe they don't equal either. So you cannot make the assumption, right? So instead of using this definition, I'm gonna use the first definition because this definition already have x1 does not equal to x2. Okay, so I don't want to force them to be equal because I don't even know if they equal to each other, right? Here, I'm going to use this instead because I already have x1 is not equal to x2. Now I want to show f of x1 is not equal to f of x2, which is the other definition of being injective. So you can say that A does not equal to B. And now I want to show g of A does not equal to g of B. So let's compute them. So now g of A, it's gonna use the second piece. So that's gonna be negative a cube. Negative a cube, what do you guys think? Is this greater than 0 or equal to 0 or less than or equal to 0? Negative a cube. Positive or negative? Plus or minus? It's less than or equal to, that's correct. Because A itself is positive. This is positive. So this is positive. With a negative sign, it's less than or equal to 0. Okay? G of B is gonna be B squared, which is clearly greater than 0 because B cannot be 0. Yeah. Clearly greater than 0. So we can see that in this case, g of A and g of B can never equal to each other because one is positive, one is non-positive, right? So we can say they don't equal to each other. That's the other definition of being injective. So in this case, the function is still injective. Does that make sense? Is this clear so far? Yeah. Okay. So lastly, which is very similar to this case. So let's suppose A is less than 0 and B is greater than or equal to 0. Then again, A does not equal to B, right? And my g of A is going to be A squared, which is greater than 0. And then g of B is going to be negative B cubed, which is less than or equal to 0. And again, you would have g of A does not equal to g of B. So make a conclusion here is that, remember, we have two definitions for injectivity. One is a contrapositive of the other, although this one is used more commonly, okay? But for piecewise functions, a lot of the time when you have different signs, we actually use this instead because it's easier for us. So pick whichever definition that's easier for you under that circumstances, okay? Does this make sense? So let me copy this part to show you I use different definitions here. I don't think that can work. Actually, I want this part. So let's put it here. Okay, so put it here to show you that in the first two, I used definition 2. In the last two cases, I used the definition 1. Without loss of generality, it can be used to merge those two cases, but I don't want to encourage people to use it because a lot of people don't really understand it and they're using it in the wrong location. So yeah, if you know what's going on, then go ahead. But if you don't have a clear idea of why it works, then just do 4 cases. Okay? Let's do surjective as well. So G is also surjective. And just like before, you need to discuss cases. But what I want to mention here is because when we do surjectivity, okay, let me go back to here. When we do surjectivity, you are not picking x anymore, you're picking y. Okay, so for your cases, it should be about y as well. It should not be, oh, x is greater than or equal to 0 anymore. It should be about y. So you're supposed to discuss cases about y, not x. Okay, so this is like a common mistake in people's solution. Because for surjectivity, we talk about y. Okay, so pick y in reals. Okay, just like before, even here, like in the last question, we discussed cases about y, not x. Okay, not x. So you wanna do the right thing. So because of that, let's look at the question. Look at my y, what my y can be. If x is less than 0, we can see that the y is always greater than 0. Do you guys see it? So here, this y is always greater than 0 because x squared is always greater than 0. Right? Clear? Yeah. And when x is greater than or equal to 0, right, this is always less than or equal to 0. So your y is always less than or equal to 0. Is this clear? So, in fact, not clear. Because this x cubed is positive. So negative of a positive number is non-positive. Okay? Yeah. So because of this, my two cases is still about positive or negative. It's just instead of discussing x being positive or negative, I'm discussing y being positive or negative. Does that make sense? But it's similar, right? It's similar. So I have two cases. One is if y is, let's say, less than or equal to 0. Okay, so go back and see the less than or equal to 0 case is the second piece. Okay, so for this piece, what x do I pick for the second piece? So I need to do some rough work. You let this be y, so negative x cubed equals to y. Isolate x, so x cubed equals negative y. X is cube root of negative y. Do you guys see that? Does that make sense? Yeah? Okay. So x is cube root of negative y. I picked my x. I need to show it's a real number. So why is it a real number? Well, is there any restriction for cube root? There is no restriction, right? Do you guys remember? Do you guys remember? Cube root, there is no restriction. The restriction is for square root. So for square root, inside has to be positive. But cube root, inside can be negative. Although here it's still positive. Input needs to be real. Yeah, it is real. Okay, you don't need to justify it. It is real. I set a trap for you. There's nothing to say. It is real. Okay? But remember I need to check it's g, right? Yeah. I need to check g of x equals to y, which means I need to decide which piece I need to use, right? So thus I need to decide which piece, although before I already know it's this piece, but you still need to justify it. So you still need to show me that this whole thing is greater than or equal to 0. So since negative y is greater than or equal to 0, x, which is a cube root of it, should be greater than or equal to 0 as well. So I need to use the second piece. So this tells me I need to use the second piece, which is negative of cube root cube, which is, maybe I'll do it in a second one, which equals to negative of negative y, which equals to y. Does this make sense? Okay, let me remind you. This is always a real number because cube roots, we don't really care inside. It's always defined. This part, I need to do it because I need to know which piece I need to use. Because there are two pieces, depends on if your x is positive or negative. So this justification is to decide which piece to use. And because I know it's greater than or equal to 0, which means I need to use the second piece. And that's why I got this. Okay? Now we can do the same thing for greater than 0. So if y is greater than 0, I can let x be what? Anyone? So again, use a rough work. Square root of y, square root of x, root y, negative root y. Do you want to pick negative or positive? It makes a difference. That's correct. We need to pick negative root y. Okay. This is a real number. Okay, let's show you why. Because I want to make sure I use the first piece. I want to make sure my x is a negative number. For those of you who use root y, this is greater than or equal to 0. Then I'm going to use the second piece, which cannot give me back y anymore. Do you guys see that? I have to pick a negative numbers to guarantee I use the first piece. Okay? So there is a trap here. Very easy to fall into, isn't it? Okay, so now I know that since negative root y is less than 0, usually this type of question will show up on final exam instead. So if it shows up on the test, the quiz, usually they'll ask you some part of it, not the whole thing, so you don't have to worry about it too much. G of x is gonna be negative root y squared, which is gonna give you y back, and we're done. So now we can make a conclusion saying it's surjective. So, hence, resist G is surjective. Make sense?
Hi, excuse me.
Yeah.
May I ask, is there any possibility that like in some of the numbers, y, even though some of maybe a and b it is y and it is larger than 0, but both of the x, one will be positive and another one will be negative? Would that be a case that will be happened during quiz or exam?
You mean this? Like this?
It's kind of like no, it's kind of like it's kind of like just the y value. The y value, even though maybe y equals to 1, for instance, maybe y equals to 1 and another is y equals to 2. But its x one will be positive and one will be negative. So
you mean for this function?
Yeah, no. Would there be any question like that during exam?
I mean, it's possible. Just give you a different function where it's not about positive or negative anymore. Of course, it's possible. Why not? For example, I think I did a question like, they give you two pieces. One is if x is divisible by 4. The other one is if x is not divisible by 4. And one is going to give you a positive y. The other one is going to give you a negative y. So it's very possible you have one positive x and one negative x, and they map to, yeah. It depends on your function, of course. In this case, it's impossible because as we showed that the first piece, all your y's will be greater than 0. The second piece, all your y's will be negative.
Okay.
Yeah. But if I give you a different question though, then yes, it is possible.
Okay, so if this kind of unfortunate situation happens, so we have to do 4 case, right?
No. No, you would not discuss this anymore. Okay?
Okay.
So for example, as I said before, like you would discuss your case based on what your input and output look like. So for example, I changed the 0 to 1 or 1 here.
Okay.
Then maybe you would not have this anymore. Then you do different cases. So you do it based on how your y look like. So for example, maybe you'll just do, if y is divisible by 2 or y is not divisible by 2, like even odd case, or like divisible by 4 case, or greater than 2 or less than or equal to 2 case. It does not mean your work is more complicated. It's just like the cases you discuss might be different.
Okay, got it. Thank you.
Okay. All right. Any other question? So our B is completed. Okay. We'll do C and D. C and D are a lot easier. It might take me like 10 minutes to do them, but A and B are more important, and you can see that they are harder. So hopefully you understand them. Do you guys understand them? Any question? Okay, so even those questions, okay, just adding something, you can easily change them. So for example, you can easily give it a square root, or give it a this. I mean, if you give a square root, it's not gonna be this anymore. Okay. Clearly, hopefully, you give it absolute value and you modify a little bit, be like this, for example. Also works, and those questions, you've seen them before. Okay, it's not like they're new. They're not new to you. You've seen them before in image questions. So go back and redo all your image questions. And for each of the image questions, you should ask yourself, is this function injective as well? Okay? And now let's do C and D. If nobody has any question, last call, any question? Okay, let's see. Absolute value equals to cases allowed to. Not always. There are a lot of them. You don't need to discuss cases. Triangle equality barely shows up anymore. Triangle equality mostly show up in image question, not surjectivity. Why? I can tell you why. Why? Because it's really helpful to figure out what the image is instead of like prove it. If you really think about in a triangle equality kind of question, it's always helpful for the first direction of image, not the second direction. The second direction is usually not that. It's, find the inverse or something like that. So it barely shows up in those kind of questions. Yeah, you don't have to worry about it that much. It's usually an image question and it's usually in the first direction. That's where it's useful. Anyway, let's do C. What do you guys think of C? Is it injective? Okay, that's great. I think this one is a lot easier, isn't it? Personally, I think C is a lot easier than A and B. H is injective, that's correct. And it's not surjective, which we'll see in a moment. It's injective, and the proof should be very simple. So let's say let A, B be natural numbers. And suppose H of A equals to H of B. Right, then, using the definition of the function, then I have A negative A equals to B negative B. And by definition of Cartesian product, I would have the first coordinate equals to the first coordinate, the second coordinate equals to the second coordinate, and they both can tell you that A equals to B. And that's all we need to prove, because I just need to show H of A equals to H of B implies A equals to B. So this shows that it is indeed injective. And not surjective. Any counterexample? Again, there should be infinitely many counterexamples. Just pick your favorite ones. Let's say 1, 1, 0, 0, 0. Okay, yeah, that's correct, because it's natural. Okay, 1, 1, 0, 0, anything else? I mean, as long as you make the first one negative number, it works too. So like -1, anything, right? Because the first coordinates can never be negative. So many counterexamples. But if you need to show counterexamples, I want you to write it properly. Okay, so you cannot just say counterexample 1, 1, or consider 0, 0. This is in integer Cartesian product integer. However, or suppose we do, it's like for a contradiction proof. Suppose n in natural such that h of n equals to 0, 0. N negative n equals to 0, 0. This implies that n equals to 0. But this is not a natural number, so contradiction. So this shows that there is no natural lemma. So it's not surjective. Okay, so if you're asking something like this, a counterexample, make sure you write it properly. Just like before, I think there was a counterexample. Yeah, so this one is another counterexample. Make sure you write it properly. Okay, don't just provide an example and that's it. You need to justify why it's a counterexample, and you should justify it properly. Okay. What about D? What do you guys think? D is it injective? Okay, I got one neither. D. What about the other people? Another neither. So let's write it here. Oops. D. It's not surjective. That's not injective. That's correct. Why? Anyone? Counterexample? Why? Yeah, exactly. So for example, consider 0, 2. 0, 2 in integer, k of 0 equals to -1 to the power of 0 plus 1, which is -1. k of 2 is -1 to the power of 2 plus 1, which is to the power of 3, and this is also -1. So we have k of 0 equals to k of 2, but 0 does not equal to 2. So it's not injective. It's also not surjective. So the common mistake here is people think it is surjective because they think this is this, but they're not the same thing. Okay? This is an interval from -1 to 1. This is a whole interval here. There's everything here. So it has infinitely many elements here. But this function has only, the image is -1 and 1. So this has only 2 elements in there. So they're not the same thing. So you can see that very many elements such as 0 cannot be mapped to. So, for example, 0 is in, okay, not surjective. 0 is in -1, 1. But that's what? But k of, but what do I say is better? Okay, I can just conclude the k of even number, or 2k, is -1 to the power of 2k plus 2k plus 1, which is -1, for some k in integer, and k of 2l plus 1 is -1 to the 2l plus 1 plus 1, which is -1 to the power of 2l to 2l plus 2, which equals to 1 for some k in integer. So no integer, hence no integer can map to 0. Okay, so we can use this to justify, to show that the image is either 1 or -1. At least it's a subset. Oh yeah, for some L. I bet. I'm too used to using K. Okay, better? Question? Nope. So we just consider even all. Yeah, in this case, yes. Because that's how it works, right? If it's even, then it's -1. If it's odd, then it's 1. But just bear in mind when we discuss cases, it's not always just 0, greater than 0, less than 0, or even odd. There are many other things you might need to discuss. We'll see some of them in the future, like when we talk about cardinality. We'll see more about discussing cases, which is pretty fun, I think. So the last topic, which is this, as I mentioned at the beginning, just watch the video. Okay, know the definition, which is not here. This is not the definition. Know the definition, know the proposition, and watch the video. Then you are good for this section. There's not much in this section, to be honest. Okay, so we are good. It's been 1.5 hours. Okay, that's the original plan anyway. So you have a question? Okay, go ahead. There is no attendance. I already took the attendance, and it's Saturday night. I don't expect everyone to show up on Saturday night. Simply use the what definition? Do you think there? I cannot tell you because I've seen your quiz already, so I cannot think. I'm not allowed to think. Okay. Thus, in inverse, or what? That they don't equal to each other. What are you talking about? Thus does not equal to. That's not. That's not what you are talking about. I hope this is not what you're saying. The definition of thus is g of f of x. Okay. If you're talking about the inverse, yes, you can use the inverse directly. I mean, you can use this definition directly, but they don't equal to each other. Yeah. Any other question? If not, good luck on your quiz. Just study hard, and I think you can do well if you to study hard. Just make sure you redo everything I said. Go back to image. Make sure you do all the Cartesian product questions. No, do all of those. You'll be fine. Do all those. Do all 1, 2, 3, 4. Master them, then you'll be fine. I don't know. Maybe tomorrow. Tomorrow, maybe. See ya.